Isaac Newton and the Newtonian Revolution, born in 1642 and died in 1727. Isaac Newton is the most influential character in Western science. Considered during his lifetime as a great intellectual hero, adulation still continues today within the scientific community without diminishing over the course of 300 years. The reason is clear. When Newton emerged, the physical world was very little understood, while at the time of his death due to his work, it was already known that he was governed by laws that had mathematical precision. Newton did not start the scientific revolution, which was already well underway when he was born. Its accomplishment was really to shape and provide the basic intellectual tools of modern physics. Newton is responsible for the three basic laws of motion by which all physical phenomena on Earth and also in the heavens have become predictable, orderly, and in principle capable of being defined and manipulated by technology. It was only in the 20th century when scientists began to dabble with the smallest of magnitudes, the nature of the atom, that the validity of Newton's laws began to be questioned. Isaac Newton came into the world on December 25, 1642, in a small village in Lincolnshire, England. His father, a manual laborer, died before his birth, and his mother left him in the care of a grandmother when he was about 3 years old to marry and live separately with Barnabas Smith, her second husband, a preacher and stepfather whom Newton detested. It is not surprising, therefore, that with this childhood, the adult Newton showed tendencies towards paranoia and violent rage. More important, however, was his ability to endure some of the aggressions he suffered. In his catalog of his sins, drawn up during his youth, Newton included threatening to burn down my father and mother Smith along with their house. It should be remembered that Newton made his first important calculations, which led to the creation of calculus theory, in the empty pages of his late stepfather's diary. Newton as a child showed great curiosity and mechanical skill, and evidently it was not in his destiny to become a farmer. In 1661, he enrolled at Trinity College, Cambridge. The university's curriculum was distinctly leaning towards Aristotelian philosophy, but within 2 years, Newton had lost his appetite for Nicomachean ethics. On his own initiative, he began to read and annotate the works of Francis Bacon, René Descartes, and other scientific exponents, acquiring a passion for mathematics and celestial phenomena. Amicus Plato, amicus Aristotle, majus amica veritas, wrote in his notebook, "Plato and Aristotle are my friends, but my best friend is the truth." In 1667, Newton was selected to be a fellow at Trinity College, a position that would lead him to liberal work after graduating as a Bachelor of Arts the following year, but the Great Plague stood in his way. The university closed its doors in 1665, and Newton returned to live with his mother, by then already a widow. He stayed there for 2 years, during which, as he later described it, I was at the best age to invent and became interested in mathematics and philosophy more than I was interested in mathematics and philosophy at any other time. In fact, building on Descartes' geometry, Newton invented an elementary calculus, the field of mathematics that provides the tools to calculate the speed of a change. The method of flows developed by Newton became indispensable for solving problems raised again after hundreds of years and caused by the erosion of Aristotelian physics. During this early period, Newton also conceived, at least partially, the universal law of gravitation and investigated the nature of light through experiments with prisms. But despite taking notes regarding his works with great care and in an almost compulsive way, he left his discoveries unpublished for a few years. The founder of modern science constantly reviewed his data, but for obscure but certainly emotional reasons, he remained silent for a long time. When he returned to Trinity in 1667, Newton was selected to be a fellow at Trinity College, a position that would lead him to liberal work after graduating as a Bachelor of Arts the following year, but the Great Plague stood in his way. The university closed its doors in 1665, and Newton returned to live with his mother, by then already a widow. He stayed there for 2 years, during which, as he later described it, I was at the best age to invent and became interested in mathematics and philosophy more than I was interested in mathematics and philosophy at any other time. In fact, building on Descartes' geometry, Newton invented an elementary calculus, the field of mathematics that provides the tools to calculate the speed of a change. The method of flows developed by Newton became indispensable for solving problems raised again after hundreds of years and caused by the erosion of Aristotelian physics. During this early period, Newton also conceived, at least partially, the universal law of gravitation and investigated the nature of light through experiments with prisms. But despite taking notes regarding his works with great care and in an almost compulsive way, he left his discoveries unpublished for a few years. The founder of modern science constantly reviewed his data, but for obscure but certainly emotional reasons, he remained silent for a long time. When he returned to Trinity in 1667, Newton was selected to be a fellow at Trinity College. In 1669, he held the position of Lucasian Professor of Mathematics, which had previously been held by his mentor, Isaac Barrow, the first to recognize his genius. Soon after, he built the first reflective telescope, which caused a great sensation, prompting his election to the Royal Society in 1672. However, when he published the essay, A New Theory of Light and Color by the Royal Society, he was attacked by Robert Hooke, then an eminence. Disgusted, Newton withdrew to continue his research in intellectual isolation. In 1684, Newton received an important visit from Edmund Halley, who discussed with him the problems at the time very current of the movement of the planets. Hooke, for example, had proposed that planetary motion could be explained by the inverse square law, but he could not explain why. The answer, that planets move in elliptical orbits, had actually been discovered by Newton years earlier through his calculations. He then turned to these questions and published De Motus Corptorum that same year, and in the course of the following years, he finished a more reasoned and resounding text, the Philosophiae Naturalis Principia Mathematica. In this work, based on a large number of observations, Newton formulated the three laws of motion and the universal law of gravitation. A body in motion moves at a constant speed unless some force acts on it. A body at rest remains so unless some force acts on it. This is the law of inertia. The acceleration of an object is directly proportional to the force acting on it and inversely proportional to its mass. This law can be expressed by the equation F equals ma. That is, the force is equivalent to the mass multiplied by the acceleration. Every action corresponds to an equal and opposite reaction. Newton's law of gravitation says that the gravitational force between two bodies is proportional to the product of their masses and inversely proportional to the square of the distance between them. The Principia, published by Edmund Halley in 1687, was a great triumph that marked the apex of Newton's career as a scientist and also sparked a scientific revolution. Although Newton rose to great prominence with the Principia and became the living symbol of the new science, the next phase of his career was fraught with contradictions. He had a short and lackluster stint in Parliament after the English Revolution from 1689. In 1696, he was appointed custodian of the Royal Mint, and 3 years 9 he became Master of the Mint, a post that enabled him to prosecute forgers, which he did with great perseverance. He was elected President of the Royal Society in 1703, a position that he held until his death on March 31, 1727. On the death of his rival Robert Hooke in 1704, Newton published the work Optics. Its authority was such at that time that the theory of light was dominant throughout the following century, despite certain inaccuracies. He was the first scientist to become a noble, awarded the title of Sir by Queen Anne in 1705. When he died, Newton left a valuable collection of unpublished works, which totaled more than 1 million words on the esoteric and mystical study of alchemy. He had developed deep research for several years through experiments by which, for example, he hoped to transform base metals into the mercury of philosophers. His research in alchemy, though lacking the careful rationalism he dedicated to physics, has long troubled scholars. John Maynard Keynes, who bought and studied his papers on alchemy, ended up calling him a magician rather than a scientist, which is an interesting statement from an economist. It is possible that both the religious aspect and the exotic principles of alchemy appealed to Newton. This led to one of his biographers, J.L. Tristensen, to suggest that Newton's goal was to arrive at the great synthetic understanding of the universe. Newton's life was marked by a series of contradictions that can make him, in the modern view, seem like an unsympathetic type. Newton was given to violent rages and unnecessarily spiteful disputes with his contemporaries, such as Leibniz and Hooke. When he died, Newton left a treasure trove of research on alchemy, contrasting his discoveries in physics, which have long baffled scientists and historians. He seems to have had a stronger relationship with Nicholas.
When he died, Newton left behind a treasure trove of research on alchemy, contrasting his discoveries in physics, which have long baffled scientists and historians. He seems to have had a stronger relationship with Nicolas Fatio de Doualière, a young admirer, and the breakdown of their friendship probably contributed to the onset of a painful but short-lived mental problem. She never married. In fact, marriage was forbidden to her because she belonged to Cambridge University and spent almost her entire adult life in the company of men. He laughed very rarely, only doing so in very special circumstances, such as, for example, when a friend said that he could not perceive any use in the study of the work of the Greek mathematician Euclid. For Erasmus Darwin, Newton explored in the manifestations of nature, cause and effect, and, by magic, unveiled all its latent laws. But when Newton died, Alexander Pope, with more elegance, wrote a poem that is engraved in the room where Newton was born in the Woolsthorpe Manor. Nature and the laws of nature were hidden in the night. God said, "Let it be Newton," and everything turned into light.